Hello and welcome to the tutorial video for focus quizzes 7 through 9, which have a variety of names, but it's really all just Pythagorean theorem. The last one throws in some special triangles that you need to have memorized to do them, but you can technically use Pythagorean theorem for all of this if they give you enough information. This is Pythagorean theorem. I would hope that you all have seen it. I think they start teaching this really early. For right triangles, the two legs A and B with the hypotenuse C, what holds true at all times is that A squared plus B squared equals C squared. So if you have two of them, or sometimes just one of them, you can always solve for the others. All right. Simple start. I've already put in all the shapes for this because I cannot draw with this tablet. Find the hypotenuse of a right triangle with sides 3 and 4. So we're going to fill in our sides. For this, it's not really necessary, but I would suggest that any time you are having trouble with a math problem, it will almost always benefit you to draw a picture, even if it doesn't really make sense for that problem. It'll help you run through the logic of it better. I think that holds true for almost everyone. I know it especially holds true for me. So draw your pictures. I probably have said this before. So anyways, because you won't be given a picture for almost any of these problems. We have a side of 3 and a side of 4. 3 squared plus 4 squared is 9 plus 16 equals 25. And then we root both sides again because 25 equals C squared. And we get C equals 5. Easy peasy. Find the length of the second leg of a right triangle if the hypotenuse is 37 and the first leg is 12. So, we're going to fill in what we know. We have 37 and we have 12. It doesn't matter where you put it. This one makes more sense because it's shorter and the last one's probably going to be bigger. And then we're going to fill in our equation. So A is 12, so 12 squared plus B squared equals 37 squared. And then we will rearrange as we can. B squared equals 37 squared minus 12 squared. And then we will root both sides and we can get our answer. So this will give us B, oh my gosh, equals root that, which we will simply do in the calculator. So you do control and then the x squared thing to get a square root. And we have 37 squared minus 144. I know what 12 squared is. And we get 35. So our last leg that we did not know has a length of 35. A rhombus. A rhombus is like a square but stretched. So all of these side lengths are the same. That's important to know for rhombus. Every rhombus problem is going to count on you knowing that all of these side lengths are the same. A rhombus has diagonals, so that's these lines. Let's see how good I can get them. That's acceptable. That's also acceptable. Of lengths 8 and 6. Find the perimeter of the rhombus. So the diagonals of a rhombus always meet at right angles, which is why you can do this problem the way we're going to do it. If this diagonal has a length of 8, then half of it, because these meet perfectly in the middle, because all these side lengths are the same, these are 4 congruent triangles, means that this length is 4. And if this is 6, then this length is 3, because it's exactly half. We already did this triangle earlier. This side length is 5. So the perimeter is 4 times 5, 20. All right. This should be a pretty short video. Ooh, spooky. This gets really hard. It doesn't. 3D Pythagorean theorem just adds an extra letter. So a squared plus b squared plus c squared. So think about the dimensions of like a box, right? That's definitely a cube. This would be A, B, and C, and the diagonal would go from one corner to the opposite corner. So if it's in like the bottom corner here, you would go directly across up into the opposite side, like a perfect diagonal. And that is, coincidentally, the longest line you can make between any vertices in a box, is this D, always. So, oh, here's another way of writing it, is like X, Y, Z, and S being the diagonal. Or it doesn't even have to be in terms of a box. That's just what it is actually looking at for the most part. They might just ask you, like, which of these is a Pythagorean quadruple, and it's the same deal. The first three squared added together equals the last squared. What is the longest diagonal of a box with those dimensions? So I'm not going to draw it. I didn't add a shape. So we're just going to 11 squared plus 12 squared plus 13 squared equals S squared. So if we root this, we will get our S, our diagonal, which is the longest diagonal in the box. So 11 squared plus 144 plus 169, I believe. 20 yeah, that's great. 20.83 approximately. S equals 20.83. And on your test, if you get answer choices that are in terms of like a simplified radical, so like some integer outside of some radical with another integer, I find it's always easiest to find the answer in decimals and then take your answer choices and plug them into the calculator. So I'll just do a random one. 6 times root 2, oops, times root 2 is going to equal that. And that would probably be what you ended up solving for. If you want to simplify the radical, go ahead. Sometimes it's really easy. Other times it's very tedious. So that's up to you. If you're quick with the calculator, I find that doesn't really waste much time. Okay, special right triangles. This is where some memorization comes in. I mean, technically you have to memorize Pythagorean theorem, but that's not that hard. There are 2 special right triangles, and there are kind of 3. Equilateral is one, but that one doesn't have any particularly special properties. All the sides are the same length, so it's like a perfectly... Wow, that's the best triangle I'll ever draw with this tablet. They're all the same length, and thus the 3 angles are 180 over 3. The other 2 are more special, I guess. So this is a 45, 45, 90. It's also known as an isosceles. Isosceles, I think. Yeah, that's how you spell it. I'm 90% sure. That is, isosceles means 2 of the side lengths are the same. So an isosceles right triangle is always 45, 45, 90. And the lengths of the sides are going to be the same. And the length of the hypotenuse is always going to be the length of the side times root 2. Which is to say, also, that if they give you the hypotenuse, then the side lengths are going to be the hypotenuse divided by root 2. So, like a side length would be the hypotenuse length over root 2, which is, you're supposed to simplify that, but since you pretty much work in decimals anyways, it doesn't really matter. So that's this triangle. All this is just a billion different ways of saying what I just said. And then there is the 30, 60, 90 triangle. And this is a little more complicated because there's more things to remember. But the shortest side, relative to the shortest side, which here is x, the other leg is x times root 3, which is if you had the other leg, the leg opposite of 60 is the longer of the 2 legs all the time. Then the shorter leg would be this length, which we'll call b over root 3. Because you have to divide this one by root 3 if you have just this number. That'll make more sense in a bit. You could also just set it equal as per the normal definition and then solve for that. Wouldn't be very hard. But regardless. And the hypotenuse is twice as long as the shortest side. And I will leave these up as reference for the next few problems to grind that into your head. An isosceles right triangle, so a 45, 45, 90, has a leg length of 9. So our x is 9. What's the length of the hypotenuse? 9 root 2. That's literally it. If it had a decimal answer, you would put this in the calculator, hit enter, and get the decimal answer. That's it. Another isosceles right triangle has a hypotenuse of 8. This is more complicated. What is the length of one of its legs? So if the hypotenuse is 8, then the other legs, so that x root 2 equals 8, right? And it's easier to consider another isosceles right triangle has a hypotenuse of 8. What is the length of one of the legs? I'm going to show you this using Pythagorean theorem because sometimes I get tricked up on what I'm supposed to do. Regardless. So we'll use S for side. We have S squared plus S squared equals 8 squared. And this is 2s squared equals 8 squared. And then we can root both of them and solve. And I think the easiest way to do this is n solve, which you can usually use for this because we have that. You usually can't use it for quadratics, but since it's inside a square root, we can. I'm going to use x here. So 2x squared. Make sure that squared is only attached to the x, as it is right now. 2x squared equals, well, root 2x squared equals 8, comma x, 5.65, yada, 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 yada. 5.65. And then, presumably, if we divide that 8 by root 2, because if this is s and that's the other one, s equals 8 over root 2. If we go do 8 divided by root 2, we get the same answer. Sometimes, I don't know, it confuses me to divide by the root 2. The Pythagorean doesn't take that much longer. And it makes me feel more confident to have done it. So up to you if you really have this down pat. Like when they give you the leg, it's very simple to just multiply it by root 2. I don't know why it trips me up to just divide by it, but since it's kind of different for each of the two types of special triangles, I don't know. Easier for me sometimes. Now we'll deal with the 30, 60, 90. Find the length of the other two sides of a right triangle if the length of the hypotenuse is 6 and one of the angles is 60. So one of the angles is 60 is just telling you that it is a 30, 60, 90. Because if one is 60, the other besides the right angle has to be 30, and vice versa. If they tell you one angle is 30, then the other is 60. And remember, too, that the angle opposite of 60 is the x root 3, and the angle opposite of 30 is the x, or our baseline. So if our hypotenuse is 6, then our x is, so 6 equals 2x, so x equals 3. So our shorter side is 3, and thus our longer leg is 3 root 3. Easy peasy. Now I have to erase that because I put it in the wrong spot. But you know what it is. In our right triangle with a 30-degree angle, the leg opposite this angle has a length of 23. What is the length of the hypotenuse? I'm too lazy to type it out. I can't spell it. So opposite 30 degrees is our shorter side, and our length, our x, is 23. So the length of the hypotenuse is 46. 2 times 23. You'll obviously get more complicated problems with this, but that is the gist of it. Honestly, on these focus quizzes, this is kind of how hard they get. There's like one challenge problem, I guess, but can't just show you that. That would be almost cheating. So now we're going to do one with an equilateral triangle, as well as a kind of like, you have to figure out how Pythagorean theorem fits into a problem. What is the altitude? So that means this length here, the height of an equilateral triangle of length 10. So what that means is that all the side lengths are 10. And because this line of the altitude perfectly bisects the other side, we know this length is 5. So this is a right triangle, and we can find this leg of the right triangle by using Pythagorean theorem. So just skipping all the rearranging, I'll write it out, but for those of you less used to it, 10 squared. When we rearrange all that, we're going to get 10 squared minus 5 squared. Root of all that equals b. So we'll go do that. 10 squared. That's just 100 minus 25. So root 75 equals 8.66. So this length is 8.66. Pretty simple once you know what you're looking for. That's a very common thing with equilateral triangles, is being able to recognize that this altitude line bisects the opposite side. So if they give you one, they've given you everything. This one's a little more complicated. Find the radius of the largest circle that can be made from a square piece of paper with a diagonal length of 7. So I've done the square and the circle, and the diagonal of the square is 7. So this length is 7. And we want to know this length. This is the radius of the circle. So, well, I shouldn't put 7 there then. Once you know to draw those lines, I'm sure you can see that we have a right triangle here. We know that this length is 3.5, and that these lengths are, since these two lengths are the same, because this radius is exactly half of the square. The reason this is an easier problem is because this is a square. So this is a 45, 45, 90 triangle. These lengths are the same, right? And then we can either just divide 3.5 by root 2, or I'll also show you the Pythagorean method. If you're crunched for time, do this. I'll show you the Pythagorean just to show you that you can. This will also come up on the SAT and ACT a lot. They love Pythagorean theorem, but they love telling you word problems that make you use it. So it's something like this, and then you go, oh, I can make a triangle in here. I can figure it out. So get used to that. That's very, very useful, I promise. So that's going to give us the right answer. But just to show you, I'll do Pythagorean as well. So we'll call this x and x. And it's the same as earlier, that x squared plus x squared equals 3.5 g squared. So root 2x squared equals 3.5. And if we go in and use nsolve, and we do that root 2x squared equals 3.5 comma x 2.47 yada yada. And if we divide 3.5 by root 2, we'll get the same answer. So that's just to show you that it also works. I don't know why I prefer to do Pythagorean. I do feel like these problems are so quick if you're used to Pythagorean theorem and like rearranging it. It's almost worth it just to be more confident with this if this trips you up. Because the first time I did this, I actually instinctively multiplied that 3.5 times root 2, which gives you the wrong answer. It gives you, I believe, yeah, it gives you the whole side length of the whole square, which we don't want. That would be this length. Is 3.5 times root 2, which makes sense because this whole thing is also a 45, 45, 90 triangle. This is very messy now, but anyways, you could also do the problem in that way. You could, for a third method, use that 7 diagonal as the hypotenuse, and this whole thing is a 45, 45, 90 triangle. And then you could do the same thing, and you would get this whole side equals 7 over root 2, and then you would cut that side in half to find your radius, get you the same answer. That's all I have for you. Again, just try to get as comfortable with the Pythagorean theorem as possible. This is 3 quizzes at once, but I do think they're easier than most any other. Acadec Math is funny because the first part is often the roughest. That's the one that carries over between years, more or less. That doesn't always hold true, so don't tell the judge I said that. But there are easier parts. Feel not too discouraged. Good luck.